Lesson 8.5, the probability of disjoint and overlapping events. A compound event is one event with two acceptable outcomes. So this is different than what we've done before. Maybe we had two events with two outcomes, so each event had its own single outcome. It's always been each event has one outcome. Now we're looking at an event where we'll accept two different outcomes. So let's say we're playing a game and rolling the dice. I want a 3 or a 4. That works. That would be one event with two accepted outcomes. There may be some intersections where one condition satisfies both events so that the events are overlapping. Let's say you're rolling one dice, you want a 3 or an odd number. Well, 3 happens to be an odd number, so there is this overlap when you roll a 3. Satisfies both conditions. If there is no intersection, then they are disjoint or mutually exclusive. So our nice little formula, the probability of A or B is the probability of A plus the probability of B minus the overlap. And we can use a Venn diagram to figure this out. So we have circle A, that's all the probability, all the outcomes for A, and then circle B, what are all the outcomes for B, and notice in the middle we have this overlap. It's counted in both circle A and circle B, so it's counted twice. Therefore, we must subtract it once so that we just have the A, the B, and the overlap just once. If there is no overlap, so it's disjoint or mutually exclusive, then that overlap equals 0, and your Venn diagram would be really boring and look like that. So let's try an example. 1d6 is rolled. What is the probability of rolling a multiple of 3 or a multiple of 5? So on the probability of a multiple of 3 or a multiple of 5. Well, that would be the probability of getting a multiple of 3 plus the probability of getting a multiple of 5 minus the probability of getting a multiple of 3 and a multiple of 5 at the same time. So on a 6-sided dice, how many sides are multiple of 3? It's 2. It's the 3 and the 6, so 2 out of the 6 sides. How many are multiples of 5? Well, just the 5, right? So that's 1 side out of 6. And how many are multiples of 3 and 5 at the same time? Well, not, because your first multiple of 3 and 5 is 15. A 6-sided die does not have a 15, so that's 0. So 2 6 plus 1 6 is 3 6, which is 1/2, which is 0.5. So 50% chance. Let's try another one. 2 d6s are rolled, so 2 dice are rolled. What's the probability of rolling a sum that is a multiple of 2 or a 3? All right, so here's our picture of all the different things you could roll. So we want the probability that we have a multiple of 2 or a multiple of 3, which would be the probability of 2 plus the probability of a multiple of 3 minus the probability of a multiple of 2 and a multiple of 3 at the same time. All right, multiples of 2. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's 18 out of the 36 that are multiples of 2. Let's go multiples of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 that are multiples of 3. Minus multiples of 2 and 3. Well, which ones do we circle twice? Well, those 1, 2, 3, 4, 5, and that one down there, which is 6. So we counted 6 of them twice, so we subtract them. And we end up with 24 out of 36, which is 2/3 or 0.67. Why don't you pause this and try page 437, number 5, whose answer is also 2/3 or 0.67. Let's say a bag contains 20 cards, numbered 1 through 20. A card is randomly selected. What is the probability that the number is a multiple of 3 or a multiple of 4? So the probability of a multiple of 3 or a multiple of 4. So that would be the probability of multiple of 3 plus the probability of multiple of 4 minus the probability of multiple of 3 and 4 at the same time. So what numbers are multiples of 3 up through 20? So it would be 3, 6, 9, 12, 15, 18, and then 21 is greater than that, so it looks like it's 6 out of the 20. Multiples of 4, it would be 4, 8, 12, 16, and 20. So that's 5 out of the 20. And multiples of 3 and 4 at the same time appear to be the 12. So it's one number out of the 20. So that makes us 10 out of 20, or 1/2, which is 0.5. Why don't you pause the video and try number 13. When you're done, your answer should be 0.1. Let's try another one. Out of 45 customers at a breakfast cafe, 42 customers brought either coffee or orange juice, so this is our or. There were 30 customers who bought orange juice, so this is the orange. 40 customers who bought coffee, of course it's probably decaf coffee. What's the probability that a randomly selected customer bought both coffee and orange juice? So we're looking for the and. So we could say the probability of orange or coffee would equal the probability of orange plus the probability of coffee minus the probability of orange and coffee. All right, so the or, it says, is 42 out of 45. Orange juice was 30 out of 45. Coffee was 40 out of 45. And we want to see both. So let's just do some subtracting. Subtract the 30 over 45 and the 40 over 45, and you end up with 28 over 45, technically negative 28 over 45. That's negative the probability. So 28 over 45, divide by the negative to make everything positive. It's about 0.622. So that's almost 2/3 of the people bought both coffee and orange juice. All right, there's another type here which actually combines things. A medical association estimates that 10.9% of the people in the United States have a thyroid disorder. A medical lab develops a simple diagnostic test for the disorder that is 96% accurate for people who have the disorder and 99% accurate for people who do not have it. The medical lab gives the test randomly to a selected person. What is the probability that the diagnosis is correct? Alright, this sounds rather complicated. Let's make a tree diagram. We have all our people, and then we have those with the disorder and those without. With it is 10.9%, so that means without must be 0.891. So just take 1 minus the 0.109, or 100% minus the 10.9%, and that gives you the 0.891. And then each of those, it could be accurate or not accurate. Accurate or not accurate. Alright, for those with the disorder, it's 96% accurate. For those without the disorder, it's 99% accurate. So we actually have two options. We could go this way, or we could go that way. How would we write this out? Well, we want the probability that it's accurate. What should be the probability that it's with and accurate, or it might be without and accurate. Well, that looks complicated, but it's an or, so we could split it up with addition. And we'd have to subtract that they both have the disorder and don't have the disorder, but that doesn't happen. You either have it or you don't. So the overlap is 0. Now, to get each of these, the probability with having it and being accurate, since it's 2 events, 2 outcomes, that was from the previous lesson, be the probability with the disorder times that it's accurate, plus the probability without the disorder times that it's accurate. So with the disorder is 0.109, and accurate with the disorder is 0.96. Probability that you don't have the disorder, 0.891, but accurate, given that you have it, be 0.99. And then you put all that together, and you get 0.987, which is really very accurate. Why don't you pause this and try number 15. The answer should be 0.4742.